Hey, so first of all, I have a different background today. We are remodeling our kitchen and it's a disaster area. So I decided to sit on a different side of the table so you couldn't see my mess. Also, as you might have been able to tell, I typically make like 3 or 4 videos at once. And so I didn't realize that that last group of videos, how poor the sound quality was. And so I'm thinking it's because I lay my tablet down flat to write. So I'm gonna try to do this up and down, like you see, like how you see me, instead of laying it flat, like when you see my ceiling fan. Um, Hopefully that helps. If not, it could just be a Zoom issue or a computer issue. I don't know. I'll see what I can do to fix it. So I'm going to get the notes up. We are starting with 9.1. And so 9.1 is Introduction to Problem Solving and Number Problems. And so this is a word problem section. The difference from this and previous word problems that we have done isn't a lot. It's just kind of a collection, kind of like that last review of all word problems before you head off to your next class. And the reason I want to emphasize word problems isn't because you're going to necessarily see these types of problems in the next class, but it's just to get you more comfortable with problems that have words in them. And that's really important for statistics. So if you are headed to pre-statistics or the statistics lab class, then pretty much all you'll ever see are words. And so I just wanted to get you used to dealing with these word problems head on, because typically students, across the board from every age range, shy away from word problems. All right, so problem 1, Michelle bought a purse on sale for $20, which is 1/2 of the original price. What was the original price of the purse? Okay, so I've mentioned this before, that sometimes you want to try to kind of crunch the numbers in your head and you just want to do some stuff. Like you see 20, you see 1/2, so you just want to say, okay, well, half of 20 is 10, so that must be the answer. And sometimes you're right, and sometimes you're wrong. So what I want to do is just write out the problem following the words without guessing, without crunching numbers randomly in my head, and that will lead to more correct answers. Okay, so we're asking for the original price, and it tells us that the sale price, the $20, is 1/2. Oh, I should underline that is also. I'm going to underline this a little differently so I'm getting all the important stuff. So, okay. The sale for $20 is 1/2 of the original. Those are all the little chunks that are important in the question. And we want to know, oh, this is important too. What was the original? Okay, so if I want to know what the original is, that's telling me right away that the original price is my variable X. That's what I'm trying to find out. Now with these little words, is and of, we've talked about those before. Is means equals, of means times, and then 1/2, I can just write 1/2. And last but not least, on the left-hand side, that sale price of $20. Okay, so it says 20 equals 1/2 times X. Now to undo that 1/2 times X, I'm going to multiply by the reciprocal. So I'm going to multiply both sides by 2, because that way the 2 and the 1/2 will cancel out. And we see that X equals 40. So does that make sense? Well, she bought the price for $20, or she bought the purse for $20. That $20 was half the original price. So we're saying that $20 is half of 40. So yep, that makes perfect sense. It's money, so I'm going to put a $sign on there. And that is the final answer. So you could see my original guess of $10 was not correct. So just putting the numbers that you read together in any order without having a plan, you've seen it be successful for you sometimes in the past, but it's not always successful. So it's better to read the problems and write them out directly. All right, number 2, Joy and her classmates formed a study group. The number of girls in the study group was 4 more than twice the number of boys. There were 20 girls in the study group. How many boys were in the study group? So we're trying to figure out how many boys. That's going to be our X. Now this question is a little longer, so I won't be able to write the numbers directly underneath like we were before, but I can kind of abbreviate it. So I'm going to abbreviate this, what I underlined. The number of girls, here's our verb was. Was means the same thing as is for math. It's our verb. And then it says 4 more than twice the number of boys. So those are our key parts. So number of girls we know is 20, because it told us that in the problem. Then we have our was, which is our equal sign. And then finally, we know how to do this from all the other sections we've done it in. 4 more than twice the number of boys. So more than means we're not only are we going to add, but we're going to switch the order. So the 4 is going to go at the end, and twice the number of boys goes at the beginning. Twice is a tricky one. Sometimes people want to multiply by 2. Sometimes people want to square it because they get confused of what twice is. So just think about a dozen eggs. If you go to the store and buy a dozen eggs, and your friend goes to the store, and your roommate, somebody that you live with, goes to the store and also buys a dozen eggs, you guys have bought a dozen eggs twice. You both did it. And so you'll know that you have 2 dozen eggs, 2 packages of eggs. So that would be 2 times 12. And that was kind of a long walk, but that's just getting us to the fact that twice means 2 times. So we have 2 times our number of boys, and then don't forget I mentioned earlier that there's a plus sign in between. And so now the hardest part for you should be coming up with the equation. That step should be the hardest part because we've already spent all that time solving equations that hopefully you are getting quite fast at it. And I'm still going to write out all the steps, but some of you might have noticed that you don't need to write -4 on both sides. Some of you can do that in your head and go straight to 16 equals 2x. And then I'm running out of room because I'm writing extra large today since I have my tablet up and down instead of laying down, but that's okay. So again, you might just jump to the answer. You might say, oh, I know that's 8 because it's 2 times x equals 16. Others are still writing out every step, and that is fine. Wherever you are at, that's what you should be doing. I'm going to divide both sides by 2, and I get 8 as my answer. I'm going to leave a little space for my units. 8, and we're talking about boys. So that would be 8 boys as my final answer. I don't like that. Hold please. I will clean it up and make it look better. X equals, there we go. Looks a lot neater. 8 boys. All right, so half of the homework is going to be those kinds of word problems where there's a lot of words and you need to pick out of the problem how to make the equation. The other half of the homework is going to be similar to what we've been working on, where it just has this one sentence. I just really wanted to keep working on sum and difference, and they get a little complicated as compared to what we were doing back in chapter 1. So we have the difference of a number and 10 is 20. Difference changes the and to subtraction. So I have x minus 10 is 20. Gonna add 10 to both sides and get x equals 30. It's always good to sneak in a little extra equation practice towards the end of this course because Whether you go to statistics in your future or algebra in your future, those are both very heavy on solving equations. Okay, and finally, we have the sum of 3 times a number and 7 is 22. So my is and my 22, going to get those in right away. And then for the rest of it, the and is where the plus sign goes. So if you get confused on when this should look like, here, I'll give you your 2 choices. Some people think it would be this, 3, and then parentheses around x plus 7. And some people think it would be this, 3x plus 7. So I want you to take a minute, reread that sentence, and think about which choice you like. So since it says the sum of, that means everything before the and goes together and everything after the and goes together. So this second choice was the correct answer, 3x plus 7. In order to be the top choice, it would say something like 3 times the sum of a number and 7. That's what the top one would be like. So that would be 3 times the sum. That's where you're going to get the distributive property. If it says the sum of, then everything after that, you're just going to write the first part, the part before the and will come first, and the part after the and will come second. Okay, finally, we're just going to solve this problem by subtracting 7. And then finally dividing by 3. So x equals 5. Okay, so we've come to the end of this section. I'm going to put up the pause the video. I'll do that right now before I forget. But what I want you to do also, besides just going off and doing your homework, is when you come back for 5-7, or even if you're not doing your homework right now, no matter what, I want you to pause the video because you have to have a calculator for the next section. The next section is going to be about square roots, and some of them, you know, what's the square root of 4? Some of them you know off the top of your head. Some of them, like the square root of 196, are a little trickier. So make sure you have a calculator when you come back after you pause the video. And we are back with section 5-7, which is evaluating square roots. Now, you can see how short this is. And in fact, a quick glance through these numbers, you might say, why did I even stop it to go get my calculator? Well, part of it is I want to show you how to use your calculator. So I'm actually going to just stop this all together so I'm bigger. Oh, that's not my face though. Well, it is my face, but it's not my live face. Haha, here I am. Okay, so I have a scientific calculator. And the way we would do the square root of something, for me, it's actually right next to the numbers. It's a little hard to see, but that square root button is right on top of the x squared. Can't get it to focus. Maybe if I put it in front of my face, it'll stop focusing on my face. Oh, anyways, you know what a square root looks like. If you don't, you'll know by the end of the section. So first thing to do is find the square root button. On my calculator, it's green. So I have to hit the green button first before I hit that. So let me see if I can do this while showing you. I'm going to hit the green, and then I'm going to hit the square root button, and it popped up on mine as a square root, and then just type in a number like 16, and I hit enter, and it tells me the square root of 16 is 4. You might not have this calculator. That's fine. If you don't have the calculator, then see if you can find the square root button on yours. On the top, mine has a name. This is harder than it looks. There we go. Mine has a name, so I could just Google that name and type in how to find a square root, or because this isn't too old, I actually have the instructions inside, so you could look at that also. Sometimes older calculators, they've been lost or destroyed, so you don't have the instructions. All right, another option is I have a calculator on my cell phone, and so if I look here, I can't actually see anything. And I have an Android, so it might be a little different for iPhones. But if I turn it, I now can see my, there it is, square root button, so I can hit it. There's no actual button, so it's harder to hit. I'll just hit it. Okay, I hit the square root button, I type in 16 or whatever number you want. This one gave me parentheses, but that doesn't matter because I'm only just doing that with square root, so I don't have to hit anything else. And then I get that the answer is 4. And we've talked about irrational numbers before. And so if you do something like the square root of 15, for example, where there's no, it's not a whole number, it's irrational, then you can see it gives you that decimal approximation. So you know that it's irrational. Okay, there's other calculators. I have my cheapy little dollar store one, but they're all at work and I can't go to work and get them. So those are the two I have at home to show you with. If you have any questions, send me a picture of your calculator and I can tell you what button to push, or send me what kind of calculator you have. Either way, and I can usually fix most calculators. Okay, last thing, and then I'll start this section. So for this calculator, if I just type in the square root of 15, it tells me it's the square root of 15. So I actually have to hit another button in order to get the decimal approximation. So all that stuff, I could fix that. So just let me know if you're having problems. Okay, so this section, that was really the longest part of it. This section's gonna go pretty quick. And some of this you might just do in your head because you're familiar enough with square roots. What I really wanted to focus on were the signs and the order of operations of these square roots. So square roots is a grouping symbol. We need to do what's inside the square root first and then the rest of our order of operations. So the square root of 81, that is inside right there. The negative is outside, so I will deal with the negative second. So I'll deal with the negative later if I need to. The square root of 81 is 9. All right, that's it. There's nothing else to do. I get the opposite of 9. Where we come into problems is where the negative's on the inside, because you can't take the square root of a negative number. In fact, I'm going to try it on my calculator right now just to see what it says. And if I type in the square root of 81, or if I type in the square root of negative 81, it tells me domain error. Some people, it might just say error, or it might, depending on what your error message is on your computer. And so this one is, and it will tell you exactly what to type in, but it'll be something along the lines of not a real number. I alluded to another number set earlier in the 7.1 section. This will actually be an imaginary number, which we don't deal with in this course. And so a lot of times you'll see in the answers, it will say something like, type in the number or check the box that says, that it's not a real number, or it could say not possible. That's another option you might see. But the point is you can't do a problem where there's a negative under the square root. Okay, for C and D, you'll notice we have some addition and subtraction going on with square roots, and they're in different locations. And so the square root of 16 plus the square root of 36, we know that grouping symbols come first. So I have to do the square roots first, and then I can add to get the final answer of 10. Whereas part D, it says inside the grouping symbols, I have the 49 minus 13. So I can't do the square root yet. I'm going to do 49 minus 13 is 36. And the final answer is You can, I'm going to make this big again. You can do all that on your calculator, but you have to be careful of how you type it in. So for my calculator, if I type in the square root and then I do 25, and I think the other one was like plus 16 or something. If I keep typing on my calculator, you'll notice that the square root kept going. And that's not, my face is way too square on here. Okay, that's not what we're doing. We don't want the square root on both of them for part C. That was what we wanted for part D. So just be mindful of where the square root is. If I don't want that, I type in my first square root, and if you see the cursor is still underneath the square root, so I'll just hit the arrow, and now when I hit plus, now that square root sign is stuck on the 26, and I could type it in again to get the 16. Other people, like for example, I'll show you on my calculator, because this is another way that you'll see it is with the parentheses. I told you on the last calculator problem I did with my phone that it didn't matter about the parentheses. Let me type it in. If I'm just doing the square root of 25, that's fine. But if I'm doing the square root of 25 plus the square root of 16 separately, if I type in that 16 right there, you're going to see I don't get the answer that we got earlier. I get a decimal answer because that parenthesis was telling your phone that everything was together underneath the square root. So I want to hit the 25, and then above the 8 here on my calculator, I have parentheses. And then I'm going to do it again, plus the square root of 16. So obviously, people's phones are different, people's calculators are different, but the same general idea is there. If it has a parenthesis, or if you're doing multiple square roots, you need to stop where the grouping symbol ends. You need to put a parenthesis there to close it, or on this calculator, you just had to hit the arrow button over to stop it. The last kind of calculator I forgot to mention, there's just kind of like the plain, this is why I told you I had a dollar store calculator, but I forgot it's at work, so I can't show you. But on some calculators, you have to do the square root second. And so the general rule of thumb is, here's my calculator. If I put one finger over the screen and it still sticks out a little bit, it's a scientific calculator. If you put one finger over the screen and it covers your whole screen, and I'm talking about a regular calculator, not a cell phone, that's different. But if you put one finger over the screen and it covers the whole screen, you're gonna have to do things a little backwards, and you might have already seen that in other problems. For example, if you have the square roots, that's what we're talking about, you might have to type in 16 and then hit the square root button second. So just email me if you have any questions. I don't want Math 80 students to go out and buy a calculator because I don't know where you're going. If you're going to pre-statistics and then statistics with me, for example, this is what I use for the whole thing. I use this for all the way through transfer level statistics. But what if you don't take it with me? What if you take it with a teacher that requires a graphing calculator? Well, then you just spent $15 in a class that's going to end in a week or, you know, in a month or whatever, however long this class is. So don't go buy a calculator, borrow one, use your phone. Well, I wouldn't say that if we were face-to-face, but since we don't have that option, your phone, or maybe you just have one in your desk drawer. So yeah, perfect. Okay, enough rambling. Let's pause this section and then we will finish up the last section in this module. And we're back. The reason I had the square root section right there, it says chapter 5, but the reason I squeezed it right there in the middle of chapter 9 was because we are going to be using the Pythagorean theorem. So 9.3 is the Pythagorean theorem. And what the Pythagorean theorem says is if you have a right triangle, so we have one in this picture for part 2, but I'll just draw one over here as best I can. It'll be a little crooked. If you have a right triangle, then you have two parts to this triangle. You have the legs, so we'll call that A and B. Those are the two parts. Those are the two parts that make up the right angle here. So those are called legs. And then you have the side opposite of the right angle, and that is C. That is the hypotenuse. And so the Pythagorean theorem says A squared plus B squared equals C squared. And what that means is leg 1 squared plus leg 2 squared equals the hypotenuse. So it's important because, as you can see, problem 1 is just words with no picture. Problem 2 is a picture with missing sides. And so you need to know which one is the hypotenuse and then which two are the legs. So again, the legs just make up the right angle. Oops, let me make it red. So we have a leg and we have a leg that make up that right angle. The hypotenuse is the long side on the opposite of the right angle. Okay, so for problem 1, I'm going to draw a right triangle, and it's just a coincidence that I drew one that looks like the answer for the picture for number 2. Right triangles can be whatever you want them to be as long as there's a right angle in there. And it says find the length of the shorter leg of a right triangle whose hypotenuse is 15. So the hypotenuse is 15. And the longer leg is 12. Well, from my picture, this leg looks longer, but it doesn't matter. The only one that matters is that the hypotenuse is opposite the right angle. So there's my mystery side, 12 is the other side, and 15 is the hypotenuse. So I'm going to say x squared plus 12 squared, because those are the two legs of my right triangle, equals 15 squared, because 15 is the hypotenuse of my right triangle. It's opposite the right angle. And it also told us in the problem, the hypotenuse is 15. So that made it easier to not have to guess. Okay, so now I have my calculator handy for these radicals that might happen in this problem. These, by radicals, I mean square roots or exponents. There's definitely exponents. So I'm going to do exponents first because there's no grouping symbols. So x squared, and then 12 squared is 144, and 15 squared is 225. And then what I'm going to do is I'm going to subtract 225 minus 144. That step out because we're still learning equations. So I'm going to subtract 144. And I get x squared equals 81. And so to finish out that problem, we need to take the square root of both sides. Because if x squared is 81, we want to know what x equals. So x equals 9. And again, I just put that square root in my calculator, or we just did that pretty much right there on problem 1 just a few minutes ago. So either way. Okay, let's try that again. This time we have the picture drawn, and it says find the length of the hypotenuse. So I know it doesn't show me per se that this is a right triangle, but I can tell from the drawing that these are my two legs. Also, it says find the length of the hypotenuse, and that's the only one that's missing here. It's supposed to be a straight line. So that is my x. So this problem is going to be written out a little differently than the previous, because this time I'm trying to figure out what the hypotenuse is. So I'm going to add up my leg 1 squared plus my leg 2 squared. So 85 squared plus 150 squared, and that's going to equal x squared. All right, all my numbers are on the left, so I'm going to follow the order of operations, and I'm going to do 81 squared. I'm going to do 85 squared. It's a pretty big number. 7,225 plus my 150 squared, which is 22,500. I'm going to add those two together and get 29,725 equals x squared. So this one, we just had to simplify the left-hand side because the x was already by itself on the right. And so finally, I'm going to take the root of that number. And it says round to the nearest whole number. So I'm going to guess that this number does not work out nicely. But when I do that, I see on my calculator that x equals 172.41. So rounding that to the nearest whole number. Whatever, I don't care what color it is. Rounding that to the nearest whole number would be 172. It did not say centimeters, it did not say inches, it just had numbers. So I'm going to leave my answer as that number. So again, if you do this on your calculator and you get fractions, not fractions, if you get decimals, don't even worry about it. It was expected because it said to round in the question. Okay, finally, we have Paul, and he is painting a house, and he's afraid of heights. He wants to know how high the top of the ladder he will be climbing will be from the ground. The ladder is 20 feet long, and he will be a distance of 12 feet from the house. So we want to know how high that ladder is. All right, so let's draw Paul's house. Here is his house. See, this is why he's painting it, because it's bright red. Nobody wants a bright red house. Just kidding. Okay, so here's my ladder, and he wants to know how high off the ground is he going to be? That's what we're trying to find out. We know that the ladder itself is 20. And then we also know that the distance from the house, so the ladder is kind of far away over here, it's 12 feet from the house. And so I did all those in different colors just to make it easier to pop out. But we have how high I did in green. The ladder I did in blue. And that distance of 12 feet from the house I did in black. And so the ladder is the hypotenuse because we have this right angle with the house is going to make a right angle. So the ladder is going to be leaning against the house. So that will be my hypotenuse. So I'm going to add up the squares of the legs, x squared plus 12 squared, and it's going to equal the hypotenuse squared, so 20 squared. So now I need to simplify all those exponents, 144 and 400. Then I'm going to subtract 144 from 400. Actually, I'm going to subtract it from both sides. And I get that x squared equals 256. Take the square root of both sides, put that in your calculator, and we get x equals 16. And since everything in this problem was listed as feet, I know the units for this is going to be feet. No rounding necessary because 256 is a perfect square. All right, so that is the end of this section and this whole module. And when we come back, we will, looks like we're going to be talking about area and perimeter of rectangles. All right, see you later.